Okay, this is the homework for the absolute extrema and the mean value theorem. I didn't realize that it wasn't recording, so I'm just going to kind of walk through these two, and then I will actually be working the rest of the problems. So for the critical numbers of the function, and it says you do not need to find the extrema. So we're just finding the critical numbers. So basically all we're going to do is, from the notes, we're doing that step 1 and step 2, but we don't need to go back and plug them in because they're just asking us for the critical values. So remember, the critical numbers can also be called critical values. And in this case, basically it means you take the derivative of the function. So I took the derivative, used the power rule. Then you take that derivative, set it equal to 0. So from there I factored out an 3x. And then you set each piece equal to 0. Zero product property says anytime you have two things that are multiplied together that equal 0, if either one of them is 0, then you solve. So that equals 0, set that equal to 0, and I get 2. Very similarly with number 2, I took the derivative, and then I set the derivative equal to 0. This time I factored out a 4x. That left me with this x squared minus 4. That can be factored additionally into x plus 2x minus 2. That's the difference of two squares. And so then I have 0 and positive or negative 2 as the critical values this time. All right, and we will then go on to number 3. Okay, so in number 3 it says find the extrema of the function on the given interval. So the first thing we want to do is check its continuity. Okay, so we want to make a statement of saying that it is continuous, if so. So in this one, this is a polynomial. We're not dividing by a variable anywhere. We're not taking the square root of anything negative, right? So this is going to be continuous. So I would say something to the effect of step 1, is it continuous? And then I would say yes. Okay. And next, I want to take the derivative and then set the derivative equal to 0. So here it's called h, so we'll say h prime. Oh, so this is like step 2. H prime of x, that's going to be negative 2x. And then I just set negative 2x equal to 0. That's not going to be, that will exist everywhere, so I don't need to worry about that. I just need to set it equal to 0. And so when I set that equal to 0, I just get x equals 0. And so that would be my critical value. So 0 is the critical value or the critical number. Okay. Now what we need to do is we need to go back to the original, okay, and we plug in the endpoint and the critical value. So you need to plug in this 0 and negative 3 and 1 into the original. We had talked about using your calculator to make that quick. This one, the math isn't too bad, so I'll just kind of do it by hand. I would expect you to be able to do this without a calculator. But if you were just doing it to make it quicker, then that's fine too. So let's see, that squared would be 9, so it would be 5 minus 9. So over here I would get a negative 4. And then I always plug in my endpoints first just so that I don't forget them, but it doesn't really matter. So let's see, 1 squared is 1, so 5 minus 1, that's going to give me a positive, oh, sorry. Yeah, that'll give me a positive 4 there. And then I plug in 0. That was my critical value. So this minus 0 squared is still 0, right? But it'll be 5 minus 0 is 5. So then the important part is kind of looking at these y values and concluding which one is the maximum, which one is the minimum. So you'll see sometimes people put stars or, you know, something like that. Here I feel like the maximum is going to be 5 and the minimum is going to be negative 4. So that's what you would write in your conclusion statement. You would say that there is an absolute minimum at, so the minimum point, this is the lowest y value, so the point would be negative 3, negative 4. And then the absolute maximum, the highest y value is 5, so the absolute maximum is at 0, 5, if you were writing it at the point. If you just wanted to say the maximum is 5 and the minimum is negative 3, that would probably also be accepted unless, of course, it was in the form of a multiple choice. Okay, so just make sure, they might also say, you know, at what point does the extrema occur, so just make sure you're answering the question. Okay, if they just want the max or min, that's the y value, but if they're asking you for the point, then you can think of that as the, you know, x and the y put together. Okay, up next in this number 4, again, the first step I want to do is make a conclusion about its continuity. So I say step 1, is it continuous? Is it continuous? And I say yes. Okay, and then I'm going to take the derivative. So step 2 is going to be to take the derivative. So here it's an f, so I'll say f prime of x is 3 times 2 is 6. Subtract 1 from the exponent, minus, and then I have 6 there. So then I'm supposed to take that derivative and set it equal to 0. So I'm going to take this and set it equal to 0. I'm going to factor out a 6 first. Not that it really matters, but equals 0. Okay. So then from here I'm going to factor this again. And again, you could have just solved it either way. You'll still end up with the same thing. You'll get x equals plus and minus 1. So I have two critical values there, positive 1 and negative 1. And then I'm going to go ahead for the step 3 and plug in positive 1, negative 1, and 0 and 3. And when I plug them in, you have to plug them into the original, because remember, we're trying to get a point. So whenever you're trying to get a point, you're going back to that original. And again, the order doesn't matter. I always kind of plug in my endpoints first so that I don't forget them. In fact, I think it's almost a good habit to kind of write them out like this first and then solve them. That way you don't forget any. So I kind of write out all the things I'm evaluating. And again, I know that I'm plugging into the original because notice here it says f of 0. It doesn't say f prime of 0. So that f of 0 indicates that I'm plugging in to the original. So when I plug in to the original, let's see, if I plug in a 0, I'm going to get, oh, that's not really exciting, 0 minus 0, right? So that's going to be 0. When I plug in a 3, let's see, that'll be 3 cubed 27 times 2, so that'll be a 54. And then minus 18, because 3 times 6, negative 6 will be that. So that'll give me a 36. And when I try to plug in a negative 1, let's see, negative 1 cubed will be negative, so that'll be a negative 2. And negative times negative will be a positive 6. So that's going to give me a positive 4 there. And similarly, this time when I plug in a 1, that'll be 2 minus 6 this time, though. And, oh, wait a second, that'll be a positive 2 there. Sorry. And minus 6, that'll give me a negative 4. Okay, so then I kind of look at these and I say, okay, what's the lowest and what is the highest? Those are going to be my absolute extrema, those also known as the maximum and minimum. So I can conclude that I have an absolute max over this interval and an absolute min over this interval. So the minimum was that negative 4, right? So we've got 1, negative 4. And the absolute maximum, the largest, was that 36, so the point would be 336 then. Okay. All right, we'll kind of scooch that down maybe a little bit. All right, I might rewrite this original here. I would probably, as soon as I see that square root, I automatically try to rewrite it with a rational exponent so that I can take a derivative. Okay? And again, don't forget, we're still kind of concluding in the, you know, your step 1 should still be to say something about the continuity. You need to say something that it is continuous. Okay, so you can say continuous, yep. And step 2 then is to take the derivative. So g prime of x, so that's going to be 1/3 x raised to the, now if I subtract 1 from there, that gives me negative 2/3. Okay, and I know for some of you, you're like, oh, that's your safe stop. I agree, that is the safe stop, but since we are trying to figure out where that's 0 or where it does not exist, right, we will need to kind of rewrite that so that we can see it. So I would say that that is also equivalent. Remember, it's power over root, so it's going to be the cube root of x squared, but it's a negative, so it's going to be in the denominator. So it's 1 over 3. This 3 is that, and then it's power over root, so it's then going to be the cube root of x squared. So that would be where that is mathematically equivalent. Okay? Okay, so this is the part where we normally set the derivative equal to 0. But in this case, we're going to also have to examine that other case of where the derivative does not exist. So to kind of demonstrate this, I kind of put it in my calculator just so you could see. Okay, so all I did was hit y equals, and then I just typed it into there, 1 over the cube root of x squared. Okay, now when I graph that, what you'll notice is, I wish it would have actually graphed it, but when it graphed it, it kind of went up like this, and then it like stopped, it jumped over, and then it kind of came back down here. So if I want to kind of see what's going on right at 0, I can look at the table. If you'll notice, at 0 there was an error on the table. Okay, so at 0 there was an error because, you know, we're not allowed to divide by 0. So it's not so much where the derivative equals 0. In this case, it's where the derivative is, where the derivative does not exist. So we are going to say that the derivative, okay, does not exist at what value? Well, that was at x equals 0. Okay, so where does it not exist? It does not exist when you divide by a 0. Again, we kind of talked about fractions, and you're not allowed to divide by 0. So the derivative does not exist when 1 over 3 cube root of x squared, when that equals 0, that's a problem. And to kind of do that, if you wanted, you could put that over 1, and you could cross multiply, and then solve for x there. Either way, you'd get when x is 0, that basically that is what gives you some bad news. I'm sorry, I kind of said it's where this equals 0, so I shouldn't have done 1 over this. Okay, it's just where this equals 0, so then you divide both sides by 3, and then you could square both sides and then, you know, take the cube root, or cube both sides and then take the square. Either way, though, it's going to be 0. So again, when the derivative did not exist, when the denominator is 0, it goes there. So I accidentally carried that 1 over, but I shouldn't have. Sorry about that. Okay, so that is our critical value. So I'm not done yet, though, because now I need to go and plug in not only the endpoints, but also now this 0 into the original. So if you go and you plug in -8, that'd be what? The cube root of -8. You can take the cube root of a negative, you just can't take the square root. That gives you -2. Then, again, I usually do my endpoints first, just so that I don't forget about them. And the cube root of 8 is +2. And then I also take 0, plug it in there, and the cube root of 0 is 0. So then you could conclude that there is your absolute minimum. Okay, the minimum there is -2. So it would be at -8, -2. And your absolute max, the biggest number there is this +2. So in this case, the endpoints actually gave me the max, the absolute max and the absolute min. That isn't always the case, but it just so happened to be this time. Okay, so we are now on number 6. And here, very similar, we are going to make a statement about its continuity. So we say continuous. Yes. Okay. And now we are going to take the derivative. So here, it's the derivative of the trig function. Okay. So when you take the derivative, remember you can take the derivative piece by piece or term by term. So I can take the derivative of this piece separate from the derivative of this piece. Now, I don't have to use chain rule this time, but if within the second piece you may have to use chain rule or something like that, that'd be okay. But here, the derivative of this is just going to be a radical 3. And then the derivative of cos is negative sign, so that negative is then going to be a positive. Oh, I forgot my 2. Sine of theta. And now I need to figure out where the derivative equals 0 or does not exist. In this case, this is going to exist everywhere. There's no vertical asymptotes I need to worry about with sign or anything. So basically, I'm going to set 2 sine theta equal to a negative radical 3, and then divide by 2, because I'm really setting the derivative equal to 0, so I just kind of did that in one step. Now, this is where you'll have to use like your unit circle or your inverse. Basically, they're saying where in the unit circle, in the interval 0 to 2 pi, is sine, where is the y value negative, so you know you're going to be down in quadrants 3 and 4. And theta is going to be there at your pi over 3. So let's see, that'd be 4 pi over 3 and 5 pi over 3. So those are our critical values. Then we're going to take those critical values and we're going to plug them into the original along with the endpoint. So we're actually going to have to evaluate it at 4 different ones here. So when we go to evaluate the original, let's see, we'll say f of 0. We're going to do f of 2 pi. Figure out what f of 4 pi over 3 is. Also 5 pi over 3. And again, we're plugging these back into the original. Oh, so let's see, when I plug in a 0, radical 3 times 0, that's just going to be a 0, and then, let's see, minus 2 times the cosine of 0, right? So cosine of 0 is 1, 1 times that's going to give me a negative 2. So 0 minus 2 is negative 2 there. Plug in a 2 pi. So when I plug in 2 pi to the original, let's see, that's going to be radical 3 times 2 pi, so I'm just going to write that down. So radical 3 times 2 pi, and then I also have the minus, let's see, minus 2 cosine of 2 pi. Well, the cosine of 2 pi is 1. 1 times negative 2 is going to be that minus 2 again. So you have to use your calculator to kind of give you an approximation for that. Okay, I'll just leave it like that for now and see what I get for the others. When I plug in 4 pi over 3, it'll be radical 3 times 4 pi over 3. Again, I'm just going to leave it like that, radical 3 times 4 pi over 3. And then when you evaluate cosine of 4 pi over 3, right, and then you're going to multiply it, so cosine of 4 pi over 3, that's going to be negative a half times 2, or times negative 2 is going to be a positive 1. And then here you plug in, you get this times 5 pi over 3, and that'll be cosine of there. Cosine there is going to be positive 1 times 2, or positive a half times negative 2, so that'll be a negative 1 there. So you just get those by plugging in. And then you can use your calculator to help you evaluate it if you need to kind of turn these into decimals so that you can kind of see. Let's see it. This one, that one is going to be your, no, that one won't be it. So let's see, that'll be an absolute minimum. Sorry, I was just kind of typing those in the calculator. Off to the side there. Okay, so your minimum is actually going to be at 0, negative 2. And then your absolute max would be at the 4 pi over 3. Oh, 4 pi over 3. And then it's that radical 3, 4 pi over 3 plus 1. And again, you can use your calculator if you need to help you get those decimals. That's not really the goal. So we've got that one. Okay, so we're on to the very last page, on to the last page of the homework there. And so here, this one definitely says you're supposed to use your calculator. So we're going to be using our calculator to model the price food index based on the basket of food between 84 and 94. So that was before I was born, but that's okay. Let's see, this is given by the function below. Okay, so before I was born until I was like maybe starting kindergarten there, we are given this crazy function. Let me just zoom in one more time so you can see that. Oh, that's as much as it'll let me zoom in. Okay, so we've got that huge thing, And where t is measured in years, blah, 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 estimate the times the food was the cheapest and the most expensive. So again, these questions aren't really tricky. They're basically going to tell you when you're going to find they didn't use the words, you know, maximum and minimum, but they're saying the cheapest and most expensive. So this is going to be an absolute extrema problem. And so to solve it, what we're going to do is we are first going to say that it's continuous, right? This is a nasty polynomial with lots of decimals, but it's still a polynomial. And so I can say that it is continuous. So continuous. Oh, why isn't this? Hold on. Okay, so we are going to say that it is continuous. And we'll say yes. Okay, so then we need to take the derivative of this. So it's kind of long. The decimals get a little bit gross, but I am going to take the derivative. It is not a very complicated derivative aside from the decimal points. So if you needed to, again, it said calculator, so you're multiplying 5 times this number, and then you're going to decrease the exponent by 1. So you get 0.0045225 t to the 4th. Okay. Plus, now we're taking the derivative of this term, so I multiply 4 times that decimal, and then I'll decrease the decimal by 1. So it'll be 0.005752 t to the 3rd minus 0.19683 t squared, almost done, plus 0.9196 t minus 0.6270, so that'll be fine. Perfect. Okay, so there's my derivative, and now I am going to go through the keystrokes on how to figure this out on your calculator. So take a minute, go ahead and put that in your y equals. Okay, so I've got my calculator here, and so type that huge decimal polynomial into your calculator, and then you can graph it. So there's the graph of mine. Yours probably looks more like this because I graphed it with a different window. So let that come through. And then our goal here is to set that equal to 0. So basically we're finding the zeros. If we're setting that equal to y equals 0, that's the same thing as figuring out where it crosses the x-axis. So really what I want to do is get this point there and that point over there. So I might adjust my window just to see it better. So I'm going to look at from, I'll look at it from like -2 over to 8. And I really only care about -5 to 5. So I'm just going to do this so that it kind of zooms in. You don't even need to do this on your calculator, though. If you didn't want to adjust your window, that's fine. You can tell from this picture that it does cross the x-axis twice there. So the keystrokes that you would want to do, you're going to hit second, then you hit this trace key where it says calc. I want to find the zeros, so I'll do 2. Okay, choice 2. Notice that on your calculator it's going to ask you for the left bound and the right bound. They're saying go to the left of where it crosses 0. So here I'm to the left of where it crosses 0. I hit enter. Then you arrowed to, it says right bound. So now it says go to the right of where it hits 0 and hit enter. Notice on this calculator it'll actually give you the 2 lines here. Not all the calculators will do that, but that's okay. And then you just hit enter again. And your calculator is going to tell you the x value is that 0.823 number, and you could tell you're in the right spot because your y value equals 0. You will repeat this process, so second, calc, 0, that's choice 2. So it's going to ask you to go to the left. I have to go to the other one, so I'm going to go just a little bit to the left of it. So I'm just arrowing a bit over, so there's to the left. And now I got to go to the right of it, so I make sure that I cross. So you can go a little more if you want, just to make sure. So I'm basically asking it to find the 0 where it crosses there. And it says that my 0 there is 5.13. And notice this is e to the negative. So that one's saying it's like super duper 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 close to 0. So we'll take that because that's with an e. So that's how you kind of do those on your calculator. I'm just going to record those things down. So, oh, I have a little bit of writing to do. So here, I took my derivative, set it equal to 0, and again, I typed it into my y equals, and I used the second trace key. And from that, I was able to get, so I could kind of put ... or something like that. T was approximately 0.823, and it was also 5.131. Okay, so we've got that. And now I need to kind of do that last step. It gave me an interval of 0 to 10 years, so I need to plug 0 and 10 and 0.823 and 5.13 back into the original. Okay, back into the original. Well, 0 is pretty easy. If you plug in a 0, that'll be gone, 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 and I'll be left with that. Okay, so you can do that. And one suggestion I have for this, to make it easier, if you really think you're going to have a hard time with those decimals, how I might do that is go back to your y equals, clear out that derivative, okay, and you can go ahead and type your original into there, and then once the original is there, you would do you could go to the graph of it and then use the table to get the values. I'm not going to spend the time to do that, but I will tell you that if you plugged in 10, okay, you'd get 96.855, and then if you plugged in that, oh, did I lose a decimal? That 0.8 number. Let's go ahead and plug in that 0.8 number. I hope that wasn't a 0.08, but when you plug that in, I wrote down that it is 99.201, and then if you plug in, what was the other one, 5. Plug that in, and I got 100.67. Make sure you're answering the full question. So estimate the times when the food was the cheapest and the most expensive. So let's see, it was the cheapest at 10, right? There's the lowest. So there's the cheapest. And the most expensive looks like it was right there. So most expensive. Sorry, I couldn't really fit it there. Okay. All right, last little section here is over the mean value theorem. So basically, your mean value theorem, you have to make sure that you're continuous, okay? If it's not continuous, you'd be done right away. And they're asking about the interval. So we are just going to take the derivative, right? And then we are going to use the average rate of change formula and set those two equal to each other and solve. Okay, that's kind of there. So here, this is continuous, right? So we could say continuous, yes, check. So now I take the derivative. Okay, so that's 6x squared. That part's done. Then I use my rate of change formula, the average rate of change, so it's going to be f of 6 minus f of 0 all over 6 minus 0. So let's see, when I plug in 6 there, ooh, cubed is 216 times 2 is 432, look at me. Then when I plug in a 0, I get a 0 over 6. So 432 divided by 6, that'll be a 72. Okay, so now what I do is I take this and that 72 and I set them equal to each other. So where does 6x squared equal 72 is what I'm trying to figure out. Divide both sides by 6. Okay, ooh, I'm starting to write big, I'm getting excited there. And so then x equals plus or minus the square root of 12. I would leave it like that, but if you look and that wasn't a multiple choice, I would say, or you could rewrite it as 2 square root of 3, right? I'm actually just going to keep the positive portion of there, because if you look at the interval, the negative one would not be in there. So I will just keep my answer as 2 squared root 3 is the final one. Okay, number 9. Very similarly, this is going to be continuous, so I say that it's continuous, yes. I'm going to take the derivative, so that'll be 4x cubed, and I'm going to set that derivative equal to the average rate of change, so the average rate of change over the interval. So I have to plug in 2, and I plug in 0. So let's see, when you plug in 2, you get 8 minus, plug in 0, and you're going to end up with the 0 there divided by 2 minus 0 is going to be 2. Make sure when you're plugging back in, you're plugging the 2 and the 0 into the original. So here when you plug in 2 to the 4th, right, 16 minus 8 gives you this 8. When you plug in a 0, because it's f of 0, it's not f prime, right, of 0, it's f of 0. So when I plug in a 0 there, I get negative 8, so it's minus a negative 8 there. So watch that. You'll get 16 over 2, which is 8. So now I'm trying to figure out where 4x cubed equals 8. Divide both sides by 4, and you get a 2. And so then you're cube rooting that, so you could just say x is the cube root of 2. And I have solved the problem. Yay! Alright, and the last one, again, the first thing we do is check for continuity. Uh-oh, this one's got a denominator, so continuous? No. So the mean value theorem cannot be applied. Mean value theorem can't be applied because it is not continuous. And everyone's like, why didn't you do them like that in class? Because those are so easy. Can't be applied because f of x is not continuous. And there is your homework for mean value theorem and extrema. Have a great day!